In this video, we're going to solve two logarithmic equations, and we can use any method to solve these equations. Of course, we've done some where you use the change of base formula, and then in the last video, I believe I used a special formula where you can square or cube the base. That's the one I'm going to use in the first one. So what we want is we want to have the same base. So the first one here has a base of 9. This one has a base of 3. So what I'll do first of all, leave this one the way it is for now. I've got a coefficient in front of this one here. We have a property that allows me to bring this up over here as an exponent. So I can rewrite the second log as log of x to the 3, comes up here to base 3. 14 stays the way it is. And then I have a property that allows me to square the base as long as I square the argument here, or cube it, whatever you want to do. In this case, to get a 9, I want to square. So I'm going to square the 3, I get 9, and then square the 3, square this quantity here, which will give me x to the 6. So squaring the 3, let me do it this way, squaring the 3, we'll make this base of 9, and then squaring the argument x to the third means power to a power, so we multiply the exponents, so this becomes a 6, and then I'm adding 2 logs, so that means I can transform this into a product. It becomes again, base 9 here, and then x times x to the 6 gives me x to the 7th, that's equal to 14. So now I have one single log here. So it's in logarithmic form. I'm going to write it in exponential form using the definition of log. This right here, x to the 7th, should equal to the base 9 taken to the 14th power. Now when it's hard for x. So I'll do here, well I'll go ahead and take the 7th root of the left side. It'll be 1 to the 7th. For the 7th root, if you want, of x to the 7th, and then also the 7th root over here. 7th root of x to the 7th, of course, is x. And here, power to a power, multiply the exponent, so this becomes a 9. 1/7 times 14 is 2. Give me 9 squared. So the value of x would be 81. And you can easily check this by plugging back into the equation. Let's go ahead and do this. Put in 81 right here. The log of 81 to base 9 would be 2. Because 9 squared is 81, so that gives me 2. And if I put in 81 here, log of 81 to base 3 would be 4. Because 3 to the 4th is 81, and then 4 times 3 is 12, and then 2 more gives me 14. So you can check it by plugging back into the original equation. Let's go to the next one here. This is just using basically one property of logarithms and a little bit of algebra. And again, we used this before. Actually, we used it in number 1 in a certain way here. If you have the log of x to some power to some base b, you can bring this out in front. And we used it in problem 1. This exponent becomes a coefficient. So in this one here, what happens is this exponent becomes a coefficient, so this becomes the log, comes over here, log of x to base 2, put this in parentheses, and what's left, if we bring that exponent as a coefficient, well, we have another log of x to base 2 equal to 4. So this times this then gives me the log like x times x is x squared, or in this case it's the log squared, so it's log of x to base 2. And you can put the square right here. That's one way to do it. Or you can just put this in parentheses, put the square here, and that's equal to 4. So this would tell me then that the log, first we solve for the log, and then we're going to solve for x. So it would be the log of x to base 2. We take the square root of both sides here. Square root of the log squared is just the log of x to base 2 on the right side. And because we want the complete solution, we take the square root plus or minus. So this would be plus or minus 2. So this would tell me then that the log of x to base 2 can equal to 2 or minus 2. So we get that equation. Then we also get the log of x to base 2 equal to minus 2. Yeah, log of x to base 2 equal 2, the log of x to base 2 equal to negative 2. So for this one here, using your definition of log, this value here, the argument x has to equal to 2 to this power. So 2 squared is 4. You get that. Or x can equal to this base taken to that power, so it would be 2 to the negative 2. And using the rule for negative exponents, that's 1 over 2 squared, so it's 1/4. So one answer is x equal to 4, and the other answer can be x equal to 1/4. Thanks for watching. We'll see you next time.